Yeah, let's grab our last folks. Thank you to those of you who noticed you were in the back row and moved up a seat. At this time also, if you haven't already, just double check that your phone's silenced. We've got plenty of room over here. And I love my front row people for being front row people. Thank you so much. All right, I think we're ready to go. Welcome everyone to the 2024 SIP reunion. I don't know. Welcome everyone to the 2024 SIP reunion. We're really happy to have you all here tonight. My name is Emily Belko. I am the new assistant director for SIP. I just started in August and have had the pleasure of working with the rest of the SIP team to pull this event together. And I am just gonna really briefly say, we are so happy that you all are here. We are really excited to hear from some of our speakers tonight. And I am going to be up and off the stage just to introduce our next set of speakers as they come around. We are gonna try to squeeze in a little bit of a stretch break in the middle of our speaking engagement here today, just so that you can stretch your legs, maybe grab another snack, refresh your drinks. But for now, I'm just gonna pass this off to Raja to get us started and introduce our keynote speaker.
Just to get people moving, let's give Emily a big round of applause, our new. Our keynote speaker this evening is Tony Tyson, a distinguished professor of physics at University of California, Davis. Before joining UC Davis, Tony worked for 35 years at Bell Labs in their physics division. While applying CCDs, charge-coupled devices, to astronomy in the early 1980s, Tony discovered a population of faint blue galaxies and then pioneered a technique called weak gravitational lensing, where these galaxies are used as distant background sources to look at the gravitational effects of the foreground dark matter distribution, essentially using these faint blue galaxies that I love so much as cosmic wallpaper. Tony's research is squarely in the area of cosmology, and he works on the distribution of dark matter in the universe, gravitational lens effects, something called cosmic shear, and the nature of these two mysterious substances called dark matter and dark energy. You see, we astronomers live in a universe that's very Harry Potter-esque. It's controlled by these two dark forces that we don't understand. Dark matter, dark energy, this is what is job security, because we're not going to solve these problems anytime soon. So Tony has led a remarkable international effort to build the first of its kind telescope and camera. It's called the Large Synoptic Survey Telescope. It was recently renamed Vera Rubin Observatory. This will see first light in 2025, about a year from now. And Tony has been the ringleader. He's been the project's director for 10 years, from 2003 to 2013, and he's now chief scientist for the project. Tony received his bachelor's degree, his BS, in physics from Stanford University, just up the road here, in 1962, and his PhD in condensed matter physics from the University of Wisconsin-Madison in 1967. He is a fellow of the American Physical Society and a fellow of the American Academy of Arts and Sciences. He's a member of the National Academy of Sciences and the American Philosophical Society. That's an incredible list of honors. As we celebrate 16 years of the Science Internship Program this evening, I am reminded that mentoring is one of the key pillars on which SIP is founded. I'm privileged that I was one of Tony's early PhD students. He is every student's dream as a mentor, more than any student could have asked for. So, without further ado, please join me in welcoming Tony Tyson to the stage.
So what Raja didn't say is that he was my best graduate student. We published a lot of really fun papers together. What you're seeing now is our galaxies and a cluster of galaxies as they orbit around. If it weren't for the dark matter that fills this cluster of galaxies, they would fly apart. This cluster would just dissipate. And so it was in the late 30s that it was first found by a guy by the name of Fritz Zwicky at Caltech, that these galaxies, the way they were flying around, exceeded the local speed limit by a huge margin. And he knew, therefore, that there was some invisible stuff, we called it dark matter in German, holding clusters of galaxies together. And indeed, dark matter holds our own galaxy together, and I'm going to give you a little bit of an introduction on how that happens. And so it's amazing that well, the war came, and everybody got busy on other stuff, and Zwicky's contributions were basically forgotten. And I'm going to tell you a story about that, and a story about Vera Rubin, a friend of ours, who started looking at our own a nearby universe, a galaxy that is much like our own. So let me, without playing this any longer, let me start this slideshow. So I'm going to talk about exploring the dark side of the universe, start with explaining how weak gravitational lensing actually works, and go through the sort of the scientific motivations before I talk about our own project. So here's a galaxy, M31, which is near us, but outside of our own galaxy, and it's rotating around. One part of it is coming towards you, and the other part is going away from you. And if you have a spectrograph, if you can measure the spectra of the light, you can actually measure the rotation. So here's Vera Rubin, 1969, 1970, with the spectrograph that she and Kent Ford had on the 71-inch Perkins Observatory telescope at Flagstaff, and my wife and I were 100 feet away using another telescope, so we got to know Vera fairly well. And so the idea is that so if you look at a galaxy that's rotating and almost edge on, not quite, one side is the spectra it's like the Doppler effect, like, you know, a train goes by and the tone changes. One side, the spectra is shifted one direction, and the other side the other direction. And everybody knew, at least we thought we knew, everybody knew that the mass was where the light was. That was the assumption. So you find a lot of mass, find a lot of light, like the sun, there's a lot of mass. Almost all the mass in our solar system is the sun. But that's not what was found. What was expected is this sort of Keplerian curve. Here we go. So here's where all the mass is, right here. Here's where all the light is in this galaxy, and you would expect all the mass to be there. And so if you have, if you know physics, you equate a half mv squared to the potential energy, gm over r. You expect that sort of Keplerian curve. And so everybody was expecting that. But what Vera found was that, oh no, it sort of flattened out beyond a certain radius. So how do you get this? You have to have some unseen matter, dark matter, holding this galaxy together. And so here's some real data for you to jump on. So here's a plot of the velocity from the spectrograph along the y-axis, and the radius out from the center of the galaxy along the x-axis. And this is the Keplerian curve that you expected to find, but these data points are what Vera found from her spectrograph. And then later, a guy at Caltech looked at the hydrogen line and extended it even further. So there's dark matter out way beyond 50,000 light years from the center of this galaxy. And it's true of our own galaxy as well. Something is holding our galaxy together. We call it dark matter. Scientists like to name things so that people think that they know what they're talking about. But actually, we haven't the slightest idea what dark matter is. And that's why, as a physicist, I'm excited about it, because it means it's new physics beyond our current model of the physical universe. So that's fun. And so here's the story at the beginning. At the beginning in the upper right, up here, there was the Big Bang. We don't fully understand that, but we know it happened because only 300,000 years later, a big gift of nature, the universe had cooled enough because of this huge expansion that occurred that the protons and electrons could get back together again from this hot plasma and release a lot of light. And so this is called the cosmic microwave background. And you see down there in the lower left a radio telescope, and then left of that the facility that I'm going to talk to you about tonight. So you would think that there's so much dark matter in the universe that it would actually pull the universe together. And that's been going on for some time. But recently, using a camera that Raja and I used, actually, using a camera that we put on the 4-meter telescope, it was found that recently, by recently I mean in the last few billion years, that's recent, recently the universe has changed its mind and started accelerating its expansion. So who ordered that? That is really weird. We've named that dark energy because then people think we know what we're talking about. We haven't the slightest idea. As somebody said, we know less than zero about dark energy. So physics is full of mysteries. 96% of the universe is made out of something we have no idea what it is. That's fun. I think it's fun. And so here's the cosmos composition. Most of it is, a fair fraction of it is dark energy. And what remains of that is dark matter. And a tiny, tiny bit, just a little spice, is the kind of stuff that we're made out of and the Earth is made out of. And so it's a preposterous place that we live in. So here's one of the techniques that we use. It's called gravitational lensing. That galaxy that's up there in the upper left you can see a straight-through image of it, straight through this cluster of dark matter right here. You're down in the lower right looking out at the universe. A lot of dark matter in this cluster. You see the straight-through image, but you also see images of it bent because Einstein taught us that mass deflects light. Marvelous experiment in 1919. And so what you find, so this allows you to reconstruct. If you have enough of these things in the sky, you can reconstruct the detailed matter distribution. So we went and used the Hubble Space Telescope and a lot of ground-based imaging. And so here's the straight-through image of that galaxy, way, way 12 billion light years distant, way behind the cluster. And in this picture, if you look really carefully, you can see it. Let's see if I get my cursor working here. Yeah. Right there is the straight-through image of that galaxy. And then you see other multiple images of it stretched around the Einstein, so-called Einstein circle, Einstein ring, and a lot of other aligned galaxies, and it's called weak gravitational lensing. And so the folks at my company at Bell Labs were kind to me and let me have a year of time on one of the best computers that we had at the time, the Cray. And we were able to reconstruct the mass distribution in this cluster of galaxies. And so the marvelous thing about this is that the mass per unit area in grams per square centimeter plotted vertically. You see all those spikes. That's all the mass that's clinging to those individual galaxies in the cluster. But what is amazing is this big extra, most of the mass is in this other almost Gaussian-shaped central distribution here in the center. So we want to do this all over the universe, not in just one place. And so the idea is, how can we image the rest of the mass in the universe? So in this cartoon, light is coming from distant galaxies on the far right, off screen, 7 billion light years away, and traveling towards us. We're on the left. And there's all this clumpy dark matter that is shown in this picture. That's all dark matter, and it clumps. And the light gets deflected by these clumps. And this is called cosmic shear. So the whole idea how this works is that if you are on the lower right in this cartoon, looking out at the universe, past this overdensity of dark matter here, to a distant galaxy that is a little bit off-center, let's say that it's round. If you have enough galaxies, the average would be round. And each pixel in this galaxy gets mapped to a new place in the sky by this weak gravitational lensing, light bending, as Einstein taught us. And it's a form of a cosmic mirage. And just like with ordinary mirages, you can invert, if you know about enough about the temperature above the ocean, you can invert a mirage and understand that upside-down ship that you see in the horizon. And so I asked one of my students, summer student, to imagine following a cluster of galaxies as it trucks along through the universe for 10 billion years. So just follow it with a telescope. And so she very kindly got, see if I can find my cursor again. So here it is, it's trucking along through the universe. And in a moment, you'll see an Einstein ring occur from a particularly interesting galaxy that's about to be scanned past the background. These galaxies, as Raja said, are far away behind. There's an Einstein ring. So then I said, okay, and that's the kind of picture that we're used to seeing when we do this work. Then I asked her, okay, so that's great. So use the same amount of mass, but put it just in the galaxies, only in the galaxies. And so she did that. And this is what you see. In astronomy, we never see anything like this. So that's, in terms of the two-dimensional apparent universe, that's proof that, confirmation, in fact, that kind of a very Gaussian, broad, diffuse mass distribution is what the way the dark matter is distributed. So Raja and I, on multiple occasions, went to a telescope. This one is the 4-meter Blanco telescope in Chile, in northern Chile. And in this particular case, we were looking at galaxy clusters. And here's a simulation. This is a computer simulation of a cluster of galaxies at late time, where you see this sort of stringy nature. This is dark matter. This is not ordinary matter. That video I opened with was ordinary matter. Now we're showing you a simulation of just the dark matter in a giant group of clusters of galaxies. And so you can do 3-dimensional mass tomography with this, because you can get the spatial dimension, and you can get the dimension in time, looking back in time. And so this is a mass of, this is an image of dark matter that we did with an early survey that Raja and I were involved in. And so this probes the physics of the mysterious dark energy as well. And so on the topic of dark energy, by the way, this is one of our employees. You don't want to be up there in the middle of the night on our 5th floor. You want to measure the history of the expansion of the universe. So that's the homework assignment. This is a fun simulation where we put a piece of graph paper on a computer behind that cluster of galaxies I showed you, and this is what it's turned into. And so we want to directly map the warp of space-time back to half the age of the universe. That's the homework assignment. So on to the project. Technology drives our new vision of the sky. Microelectronics enters in a couple of different ways. It allows you to make more transistors per unit area. It also allows you to make and put more pixels per unit area on a charge-coupled device imager. Software is extremely important. We're pushing technology in all these areas. And finally, large optics fabrication. So in this project, we pushed technology beyond the current limits in 3 different areas. We now call it Rubin Observatory because we just recently renamed it after Vera. And I won't read all of these things, but this is not to scale, obviously. This is a drawing, a picture of the camera on the left and the telescope on the right, and we're putting the 2 together right now in a commissioning period. The way it works, it's three mirrors, but 2 of them are together on the bottom. So the light comes from the distant universe, comes and reflects off the outer primary, off the secondary, off of a very, very fast tertiary mirror up into the optics of the camera. This is a cutaway drawing of the camera, and on the right, the focal plane with the moon for scale. So it covers a fair amount of real estate. We can actually observe the entire sky over and over again multiple times per week, creating a color digital motion picture of the universe. No one else is crazy enough to do this, so there's no competition. So it's a wide, fast, deep survey. We're covering a very wide part of the sky. We're doing it fast, and we're going as deep as the Hubble Space Telescope. 37 billion objects in space and time. Each sky patch will be visited over 800 times, about 1,000 times now. 30 trillion measurements. And we have to figure it all out. You're not going to get this on your laptop. One of the areas that we're going to have assured discovery is things that go bump in the night, optical flashes. On the left panel is a before image from our survey that we did ages ago. On the middle one is an after image, and the right is the difference between the two. Something flashed. And we're going to find lots of those. The estimate is we're going to be finding about 8 million per night of these with our project, with our new telescope. And we're going to alert the entire world, scientific community, every time one of them goes off. So if you guys give us your cell phone numbers, we'll. So after in questions, you can ask me how we're really going to handle that. The telescope itself is complete now. This is sort of nearing completeness, picture of it inside the dome in Cerro Pachon, which is near La Serena. We're actually nearing completion now, as I mentioned. And we have a little commissioning camera that's on the telescope, and it's taking data, and it's just beautiful data. And so the commissioning is in progress. And just my last slide, this is 1.7 parts per million of the full survey in a simulation, of course. Almost every 10 pixels is a galaxy. And so lots of data, and it's going to be fun. You're going to be able, the public is going to be able to go and ask a question of the universe. We're going to make it possible for you to go and ask a question of our database. And that'll be fun, because I really think that the general public is going to be less biased than we scientists are. And they're going to say, wait a second, that looks really weird. And we scientists are biased because we know what galaxies are supposed to look like. But so I think most of the discoveries are going to be made in that so-called time domain. Anyway, that's my talk, and please ask some questions. I have a few slides beyond this if you want to ask questions.
So for those of you who are so curious that you cannot wait until the end of our speaking sessions to ask Tony a question, we have time for a couple of folks. If there is anything you'd like to have them clarify or follow up on or go even more into depth with.
Yeah, could you elaborate on how you plan to build that database and how users can interact and ask?
That's a really great question. So how we're going to build the database and how our users are going to interact with it. We're going to have something called data brokers. And there are 8 of them so far. And the data goes directly to the data brokers. These alerts go out immediately within 2 minutes of the shutter closing of something that has been discovered. Various data brokers specialize in different kinds of phenomena, different things. And so you'll be able to ask a question of the data broker. And so you're not going to be flooded with 200 petabytes of data. Which is the amount of data that we're going to have. So my question is going to be, I'm going to subscribe to the data broker that allows me to ask the question, give me information on all the objects that you cannot understand, the objects that you cannot classify, something unusual. I'm more interested in the discovering the unknown. But yeah, and so many of you probably have heard of the Zooniverse, and you can go to the Zooniverse, you can Google Zooniverse, and we're going to be offering projects, 5 or 10 projects through Zooniverse. Anyway, that's a good question. Oh yeah, sorry, yeah, didn't see you.
Modified theory of
Modified, oh, okay. Modified theory of gravity, yeah. And could the dark matter be wrong dynamics? Introduce some kind of tweak in general relativity, so it's not quite general relativity. That had a fairly long life, but the most recent data indicates that it's not consistent with the most recent data. The dark matter is there. It's not modified gravity as far as we can understand. We don't know what it is. It's something. It could be a wave. I have an experiment looking for wave-like dark matter. It could be a particle. It could be something heavy. It could be tiny, tiny black holes. It's a huge mass range. Anyway, okay, that was a couple of questions maybe.
One more burning question. Let's go. Oh.
Yes, sir.
Dad, go ahead.
Yeah.
Right. So you mentioned black holes,
Yeah.
and the maximum curvature of space-time is like black hole, right? Have you noticed any differences in terms of how the measurements have come out for dark matter, dark energy around the black hole?
That's really hard to do because, well, so one of the things you can do with black holes is you can look at the orbits of stars around them. And that's been done very nicely recently and with the spectrograph. So you see the velocity, you can see the velocity of the stars. That sort of maps out the gravitational potential around the black hole. And that's how you get the kind of that allows you to measure the mass of the black hole. And so we can do that. But can black holes, little tiny black holes, be the dark matter? We don't know. That's an interesting possibility. I mean, if one came by us right here, I don't think we detect it.
May I respond to that?
Yeah.
So this is an area of active research.
Yeah.
It's not a question of whether black holes can do it, but the more massive the individual black holes, the fewer of them you need. That is ruled out. The high mass, small numbers ruled out. People are starting to rule out asteroid mass.
Yeah.
That isn't ruled out. So this is a Stefano Profumo, among others at UCSC Cruz in the physics department, is actively working on it. There are many others around the world.
So far, all of the effects that have been measured is based on an understanding of dark matter and its effects.
Yeah, and gravity.
Not really
Yeah.
energy and its effects.
Right. Yeah. Yeah, we can measure the expansion rate of the universe. That's actually pretty easy to do because you can do that with the spectrograph. So, who ordered the universe to suddenly start expanding more rapidly recently? That's crazy.
Great. And I saw Stefan. You're our last question. And
Sorry,
if anybody
yeah.
has additional questions for Tony, he'll be sticking around for dessert. So I do encourage you to come have a conversation with him.
Okay. Thanks.
Yes, question? Okay.
Yeah.
So I was curious, how is what this telescope is going to do different from James Webb?
That's a really good question. How is this different from James Webb? So these wonderful space telescopes like JWST and the Roman Space Telescope, they complement us in a couple of ways. They can go far into the infrared, which is something that we can't do at the bottom of the atmosphere. But they also have a tiny, tiny field of view, really tiny. And we get the whole sky. So it's very different. We can go almost as faint as they can go, but we can do it over the entire sky. And we do it all night long for 10 years, creating a digital color motion picture database that can be queried. So those guys are going to follow. So one of the things that we do is something called multi-messenger astronomy. So we find something that pops off. They're going to go and look at that right away at that place and see if they can explain it. Okay.
All right. Thank you so much, Tony, for kicking us off. We are going to transition to hear from a few of our SIP participants, parents, interns, mentors, RAs even, over the course of our evening. And so we're going to start with some of our young researchers. It is my pleasure to introduce both Michael Lin and Colette Lamb to the stage.
Good evening. I'm Colette Lamb. I'm a junior from Consumnes Oaks High School, and I was part of the Biomolecular Engineering Project 2.
Hello, everyone. My name is Michael Lin. I'm a senior at Stockton Early College Academy, and I was an official intern for Physics 03 and an unofficial intern for CSE 04.
I'm going to start off by talking a bit about my project and then move on to how SIP helped me grow as a person. BME is where we analyze genomic data by running a gene's code for protein or mRNA sequence through annotation tools to look for abnormalities. These abnormalities are useful for when we want to improve healthcare or for scientific research. Our research focused on improving CAT, which is a comparative annotation tool. And we do this by running the same sequence through 2 versions and seeing which one gives the more accurate result. This meant that I needed to learn how to use Bash, which is a shell program needed to run these annotation tools. This was very hard for me at first, and I struggled a lot because I had no prior knowledge of this. But I also didn't have the confidence that I could do any of the stuff that I accomplished during the summer. But everyone around me was very supportive, and they helped me feel as if I belong. And one of the most remarkable aspects of SIP is their sense of community and collaboration among the interns. My co-interns, who have more experience in BME, they helped me catch up and gain the skills I needed to contribute to our research project. As you can see, we spent a lot of time working on our projects in the library. I remember spending at least 3 hours a day with my team researching. And the thing about this was that SIP coordinated lots of group activities like beach days, the 7-Eleven trip, paint nights, and etc. And this helped me get closer to Michael and to a lot of my other friends like my roommates. After SIP, we kept in touch, and we would spend time together, like going to Six Flags or Disneyland. I had an amazing time being surrounded by so many like-minded peers. And this internship not only helped me with my research skills, but it taught me about stepping outside of my comfort zone, like talking here today, what college life is like, and interacting with new people. I've met some of the most awesome people here at SIP, like Michael and a few others. Thank you, Raja, Anand, and all the staff for running this amazing program.
All right, thank you, Colette. And moving on to my experience at SIP. So my SIP internship program could sort of be categorized in 4 times. So, of course, I was accepted in late spring, officially into Physics 03. And then in June, I began preparing for my physics internship. So I had to learn the basics of GNU Octave, brush up my seawater electrolysis skills from chemistry and physics, and also sharpen my skills in deriving equations, which became really handy later on. And once I arrived on the UCSC campus in July, I actually officially started my physics internship, and I really loved it. And I met Terry, which was the CSE 04 mentors, or one of them, and he introduced me to the project, and I'll get more into that later. But in August, I began preparing for my final presentations, so I had to build my final projects, and even though it was very stressful, I think the skills I learned to manage my time and also my research skills are very valuable, and I think it was all worth it in the end. So my physics internship's big idea was essentially seawater electrolysis and simulating it through a graph. and I'll explain why we wanted to simulate it and also the relevance of our project and our final result as well. So essentially, seawater electrolysis is the process that splits seawater into two components, green hydrogen and oxygen. And we really wanted to focus on gathering that green hydrogen to work as fuel and replace coal fuel or carbon emitting fuels like fossil fuels. And even though the physical trials for this were going great, we wanted to code a visual simulation of seawater electrolysis to avoid toxic byproducts of our physical trials, in addition to it being incredibly resource intensive and taking a lot of time. So to do this, we had to derive a lot of equations, and this is just one example of one of the equations my co-intern and I derived. This took about a couple days of work, and as you guys can see, we started with that small equation and somehow ended up with that bottom equation there. So it was a lot of work, but this ended up speeding up our process a lot in the end. So this was kind of our final project. Me and my intern were able to successfully graph two electrodes interacting with one another while accounting for the seawater around it. And I think if we were to continue this project, we would definitely go for a 3D simulation so we can actually compare and contrast the physical trials to our simulated trials. Moving on to CSE 04, which is computer science and engineering, and specifically we were working on pedestrian annotation. So before I explain CSE 04, I should explain why I had two SIP projects in 1 year. So like I mentioned before, I was initially accepted into Physics 03, and even though I really, really loved the project, there was no denying that I had a clear passion for computer science. Miraculously, I met Terry, and luckily he was a mentor for CSE 04. I didn't even know he was a mentor, but he introduced me to the intern team, and he was really welcoming, and he showed me a lot of the project, and I was, of course, really invested, so he invited me to join the team. And even now, beyond SIP, I still work with Terry, Mr. Muqtadir, and the intern team of CSE 04. So CSE 04's big idea is pedestrian annotation, and us researching it on its applications to the real world, and of course coding an annotation tool for it. So I'll dive into the relevance of it and also the final result of our project. So pedestrian analysis can actually be applied in two major fields. So the first being AI models. We wanted to train AI models and use our database to fuel like these new fields of research. So think self-driving cars or non-playable characters in video games. And speaking of databases, when this project was initially started a couple years ago, there wasn't a reliable database to lean on for researchers to pull reliable data from. So our research was essentially to create an annotation tool for people to annotate pedestrians and I guess fuel a database for researchers to take when building research papers and identifying new pedestrian archetypes. So SIP gave me a lot of skills, but these are just some of them that I personally use now. So GNU Octave from Physics 03, React, and Material UI from CSE 04. Those are some of the big ones. And I think these three skills have really helped me even beyond SIP. So my research skills I learned from Physics 03 and learning React and Material UI from CSE 04. They've even helped me out in my personal passions. So for example, when I was building my personal nonprofit, Volunteero, I was able to apply my research skills in, that I learned from Physics 03 and my web development skills that I learned from CSE 04 to really expedite this process. And ever since I came back from SIP, I was able to make a lot of progress with this, and it's really only to thank from my experiences with SIP. So thank you, Anand, Raja, and all the faculty that made this possible. Thank you.
Let's hear it one more time for Michael and Colette. And we just heard from three wonderful folks to get us started here today. What I will ask before we bring our next speaker up is if we can all stand up for a moment. And for folks on stream, hello. We're going to take a little bit of a stretch break. And if you can, we're gonna just get our hands above our heads and wave them around for a second, and then turn to your left and wave, turn to your right and wave, turn to a neighbor, say hello, give them a big wave. And then Raj is gonna steal the stage. Come on up.
This thing in my hand, is this live? This thing in my hand is a selfie frame that was started in time for the very first reunion. I've had the pleasure of writing 2,000 plus names on this. So come take a look. Don't spill any liquids on it. But feel free to use it to take pictures. We also have a surfboard, random surfboard that someone gave us 1 year. No connection to SIP otherwise, except that someone just gave it to us. But it was, it became a substrate to test out what was then the new SIP logo. So the painting, the black and white painting is mine, not the blue painting. The blue painting the surfboard came blue.
Thank you, Raja. You all can grab a seat. Michael and Colette alluded to the faculty members at UC Santa Cruz playing a really pivotal role in their experiences and then overall the success of the SIP program. So I would love to introduce up to the stage our faculty member, David Lee.
Hi, everyone. It's really great to be here. As I was thinking about what to share, I thought I would especially speak to those who are early in their career, recent SIP alumni, incoming SIP students, and share some thoughts about research and my own research journey that hopefully will be a little helpful. And one of the things that jumps out at me when I reflect back on my own path, all the way back to, in your shoes in high school, is that I would never have been able to predict back then where I am now. There's so many different winding paths that I ended up taking, and it's interesting how they all connected to bring me to what I do. When I was in high school, I was very much a math person. I had an embarrassingly narrow-minded love for math, and I didn't really think much of biology or social sciences, which is ironic because I ended up doing research in biology and then in the social sciences. And in college, I worked on these mathematical models for biologically inspired computation. And through that, I started to get fascinated with biological systems, with how they use randomness in surprising ways, and how you might be able to learn from them to develop models for probabilistic computation. And then I went to graduate school, and I thought that's what I wanted to do. But I couldn't find a faculty advisor to work with. I almost dropped out. And then I took a randomized algorithms course with the faculty. I ended up joining his lab, which was called the Social Algorithms Lab. And I found that I could apply some of the models that I had been developing for biology to social systems, which was really exciting for me because it brought together two parts of my life that I never thought connected. My love for math and technology, and my passion for volunteering, making a positive impact on society. And as I engaged in that, I started reading social science research on polarization in society, on voting theory, and that started opening my mind to appreciate the social sciences. Now, at that point, I was still primarily using mathematical models, but as I started to work on those questions, I started realizing that mathematical models can only go so far for actually designing solutions in the social domain. And so towards the end of my PhD, I started to learn design, and I started to learn user research, and essentially how to conduct social scientific research to more deeply understand the complex context around the different needs that humans have, the different social needs, societal needs that we have, which brings me to where I am today, where I run the Tech for Good lab and think about how to design systems that advance the more flourishing future of education, work, and communities. My point in sharing my journey is to show that research is a great place for learning to be humble, to be curious, to be open to learning new things, willing to engage and go deep into things that you initially have no understanding of or might not find interesting. There's so much we don't know in every field. And it's surprising how everything is connected to each other across fields. I like what Tina Seelig says. She used to be the director of Stanford Technology Ventures program when I was there. And she says that some people think you need to have a vision before you can engage. You need to be passionate about something, right? But actually, it's the reverse. It's when you start to engage that you start to be able to envision. I feel like these days there's a lot of pressure for high school students. You have to figure out what you want to do right now. You have to optimize all the activities for your college applications. And I think that sometimes optimizing your time and your learning to those external pressures, it can sometimes prevent that deep engagement that helps you develop authentic passion and vision. I see the SIP program as this really unique opportunity for high school students to expand their world way beyond the classroom, to get a taste of experiential project-based learning, to learn the humility and curiosity that comes from working on advancing knowledge. I've personally had some SIP students who engaged really deeply, who continued on past the summer, ended up co-authoring papers, ended up leading teams of college students while they were in high school. And so I'll just end by encouraging all the students here to go into the opportunities that you encounter with a curious, humble, and engaged mindset. Don't take on too much just because everyone else is doing it. Instead, focus on going deep, really enjoying and developing authentic passion for the things that you do take on. Thanks, Raha and the SIP team, for providing students with that very unique opportunity.
Let's get another round of applause for David. Thank you for sharing those insights. And I think that's something that we see evident across the scope of high school student experiences, right? Being able to lean into those few things that you feel really passionately about, want to explore further and further. And then one day you look around, Tony Tyson, and you are still observing the sky and completely passionate and in love with the things that you're doing, right? And that's really our goal, is to allow you all an opportunity to explore your interests and passions, interest for research, passion for a certain subject, learn what is for you, learn what's not for you. But thank you for reminding us to lean in. We're gonna invite up our next speaker. Tiger Chang is one of our parents. So welcome, Tiger.
Thank you, Emily. And good evening, everyone. I'm Tiger Chen, father of Jerry. And I'm thrilled to be here with all of you here tonight. As a SIP parent and an electrical engineer here in the Valley, watching Jerry passionately participate in the UCSC Science Internship program over the past 2 years has been an incredible journey. In the summer of 2023, SIP was hybrid, a unique experience despite the challenges of balancing in-person and virtual activities. SIP's dedication to providing a comprehensive learning experience was very impressive. Jerry did the 10-week literature project to study the experience of chronic pain and the pain gap in Western medical practice, mentored by Catherine Rogers. Even though Jerry only attended the program in person for 3 weeks, he made many friends from across the world, and on a whim, his roommate's project stood out, especially to him, inspiring him to pursue the same project in the following year. The final presentations were eye-opening and well attended by SIP families, like a festival. Jerry's first summer at SIP transformed him as a person and opened many new doors for him in the field of scientific research. I'm also glad to see Jerry keeps in touch with his SIP 2023 friends. As a highlight, right after getting driver's license, Jerry drove to visit his friends at Stanford, some of which he hadn't met in over a year. Fast forward to 2024, Jerry was excited to return to an entirely in-person SIP. He moved in a couple of weeks earlier than normal to enjoy the friendship and redwoods. Filled with experiences from the previous year, Jerry was clearly all in. He pursued the structural characterization of few-layer chromium trihalides using 4D STEM under the supervision of Ham Prasad Busal, thank you, and Professor Aimin Yan. I still remember before the program officially started, my family visited the 2D materials lab at UCSC physics department. Guess what? On a weekend, the lab was full of UCSC student researchers doing experiments and analysis. Professor Yan's students gave us a very detailed tour of the lab, so appreciate that. For 10 weeks, the hands-on experience in a state-of-the-art lab, face-to-face interactions, and the sense of community was invaluable to Jerry. Here's an example that I can share. During our Thanksgiving dinner with friends, when discussing the X-ray imaging of 2D materials with a Stanford SLAC research scientist, it was my pleasure to see Jerry skillfully pull out a recent scientific paper from his phone to validate a point on the optics topic. It's not the optics Professor Tyson talked about, actually far from that, but on the right track. For parents, I think SIP not only provided interns like Jerry with scientific skills and knowledge, but also fostered a sense of curiosity and resilience. They learned how to navigate challenges, think critically, and communicate ideas effectively. I think these are the life skills that will benefit them very well in any future endeavor. So if you're considering summer programs for parents, I can confidently say that SIP can be a very wonderful investment for your child's future. It offers a very unique blend of academic rigor, practical experience, and personal growth. The mentors are very dedicated, the projects are intriguing, and the community is exceptionally supportive. So be a round of applause for this very amazing people. Big thank you goes to Anand. Emily, Professor Raja, who is the soul of the program, and the UCSC SIP team for creating such a memorable experience. As a UC alumnus, I see this program as a classic embodiment of Let There Be Light. So I wish SIP many more fruitful years of inspiring young scientists across the globe. Thank you.
You all know the deal by now. Let's give another round of applause for Tiger. Thank you so much. On that note, we can't run this program without our faculty. We can't run this program without our staff. We absolutely cannot have this program without parents being involved in supporting their interns and students and children to engage in things like this. So if you are a parent of a SIP alumni, could you please stand for a moment so that we can recognize you? Wow. Thank you so much for doing the hard work of raising your children and leaving them with us for the easy parts. We know that you put a lot of love and a lot of time and energy into allowing them to explore their passions. What we're going to do at this time is take a quick 5-minute break. When we come back, we're going to hear from our resident assistant, Shivani. So what we're going to do is Sean, our musician out here, is going to play some music for us for about 5 minutes. And we're going to play musical chairs. So once you hear him stop playing, it means that it's time to come back and grab your seat. But we are going to give you a chance to refresh your beverages. I believe catering has just put out some desserts, and let you grab something before we finish out with the rest of our speakers for this evening. So we will be back in about 5 minutes.
lost or flew away. Waiting around is the ways, and counting the days since November. Loving is good as they say. Now I'm so lonely. Oh, I wish I find a lover that could hold me. Now I'm crying in my room, so scared they go us. But still I wanted more, more, more. I gave a second chance to Cupid, but now I'm left here feeling stupid. All the way he makes
We're gonna keep testing. There we go. Wonderful.
Hopeless girl seeking someone who will share this feeling. I'm a fool for love, a fool for love. I give a second chance to Cupid, but now I'm left here feeling stupid. All the way he makes me feel that love isn't real. Cupid is so dumb. I give a second chance to Cupid, but now I'm left here feeling stupid. All the way he makes me feel that love isn't real. Cupid is so dumb. Me dejaste el corazón vacío, ya le das calor y yo muero de frío. Me pregunto dónde la conociste, pero creo que sé. Esa noche pasó de 5-2 y percocé. Tenía llamada tuya perdida en el cel. Imaginando lo peor, ya no sabía qué hacer. No sé si hice bien, pero llamé. No me gustó lo que escuché. Yo quería hablar con vos, pero otra voz me dijo que no te ilusiones más con él, porque ya no va a volver. Corté el teléfono y supe que me dejaste el corazón vacío. Ella le das calor y yo muero de frío. Qué ilusión creer que tu amor era mío. Pensé que éramos dos, pero me ha mentido. Éramos tres contigo, no. Perdón pa' que sé que no es sincero conociéndote. Y aunque pude sola te necesité. A lo de siempre desaparecete. Baby, y no te pongas loco si me ves perreando con otro contra la pared. Que tú ya lo tuviste y lo dejaste perder y sabemos ya. ¿Y qué quieres ahora? Nos fuimos, no me hables de amor y no paramos. Seguimos, y aunque caminamos en lo oscuro, salimos. Te faltó valor y yo tuve compromiso. Me paré del piso. No sé si hice bien, pero llamé. No me gustó lo que escuché. Yo quería hablar con vos, pero otra voz me dijo
All right.
que no te
I
ilusiones
think
más.
we've got about 85% of our crowd back. You know, I had a little bit of a fear that if I told you the rules to musical chairs, when the music stopped, you weren't going to come back. But here we are. And I'm going to say thank you to those 8 or 9 folks who heard the music stop. And I'm going to crown you winners of tonight's reunion. So, we're about to jump into our final group of speakers. We have a few folks who couldn't join us in person today, and so they have prepared a couple of videos. So the first person that I am going to introduce is Shivani Kota. She was one of our resident assistants this last summer. And then she is going to introduce our next speaker, one of our mentors, Stephen Umbarger. So I am going to give the stage to Shivani.
Hey everyone, I hope that you all are enjoying the 2024 SIP reunion event. For those of you that don't know me, my name is Shivani and I'm a third year astrophysics major here at UC Santa Cruz. But more importantly, this past summer, I've had the privilege of being one of the residential assistants at Science Internship program. I couldn't make it, unfortunately, in person for today's event, but I wanted to relive some of the great memories that were created together in the summer. It's so crazy how much time flew by from when SIP first started and ended, and it feels like just yesterday when the staff and I were all welcoming you guys into the dorms in College 9. Being a part of SIP as an RA has given me the rare chance to work with you amazing students and staff from various backgrounds, and it was so awesome to see all the outstanding research that was being conducted by you talented high schoolers. Not only the students, but the staff created such a wonderful community, and it was so awesome to see everybody interact in there. And I'm so glad that I could be able to contribute a little bit of it. I know that sometimes endless work can be so tiring, but I love that every student in the program could de-stress by going to one of the fun activities that the staff and I worked hard to plan over the weekends and the weekdays, including beach days, paint nights, and on the weekends getting cool experiences like exploring San Francisco and going to colleges like Stanford and UC Berkeley. I don't know about you, but my personal favorite includes Raja and Anand dressing up as Santa Claus in the Christmas in July event, and also the talent show night. Open up your mind and feel like me. Open up your plans and then you're free. I hope that your time and your hard work inspires you to further your academic interests, and I wish you all the best of luck in your future endeavors. Bye! Wait, I have one more thing to share with you. Most of the SIP program includes working on all the amazing research, but more importantly, working with your mentors. And I know just the mentor to call to talk to you guys. Here's presenting Steven.
Hi, Shivani. Yes, I would love that. Thank you so much for the introduction. Hello, I'm Stephen Umbarger, and I'm currently a fourth-year undergrad at UC Merced. I met Shivani over the summer at UC Santa Cruz when I conducted research under the guidance of Professors GuhaThakurta and Philippines. Before the summer started, Raja encouraged me to become a mentor at SIP. However, I was nervous as I started my own research journey the summer of 2023 and felt that I didn't have the expertise to teach good research skills. But thinking about my own current research advisor and mentor, Professor Sarah Loveman, who greatly impacted my academic career, I wanted to be a supportive figure for a group of individuals. This led me to apply as a mentor and take on 6 interns on our project of comparing 6 star clusters in the Andromeda Galaxy using Keck adaptive optics and the Hubble Space Telescope to see which telescope yielded sharper images. At the beginning of the summer, I struggled to assign weekly tasks and felt that I wasn't teaching good research skills. But over time, I was able to provide coding assignments along with lectures on astronomical topics. Since we had a big project focusing on reducing Keck adaptive optics data, comparing the data between Keck and Hubble, and creating 3D models of all of our data, I made sure that all of my interns rotated roles so that they all learned the valuable skills of coding, data analysis, and problem solving. Working with my interns, I learned how to become a better leader. I learned how to properly divide up big tasks to increase work efficiency, and I also learned how much I enjoyed advocating for higher education, as some of my interns expressed to me at the end of summer how they wanted to pursue astronomy further in college. Now, as I apply to grad school, after I receive my PhD, I hope to become a professor at a research institution where I can continue to conduct cutting-edge research along with mentoring the next generation of scientists, something I was so happy to experience with SIP. SIP is an amazing program where it introduces high school students to cutting edge research, along with forming connections that would last a lifetime. I still keep in touch with my interns, and they would like to say a few words about their summer experience.
Hello, my name is Amy Singh, and I'm from Pennsylvania. Through SIP 2024, I learned how to approach and problem solve through challenges in our research, whether that was while analyzing star clusters, creating 3D models of them, or comparing Hubble and Keck telescope images. Moreover, I found it incredible how open and willing this community is to supporting one another, both within this research group and amongst other groups.
Hello everyone, I'm Andre from Mexico, and last year during SIP, not only did I learn a ton about astrophysics, but I also learned so many niche things about random topics that I didn't already know. I also made everlasting memories and friendships with people that I still talk to this very day.
Hi, my name is Kota and I'm from the Bay Area. While participating in SIP 2024, I explored optical imaging, comparing the Keck and Hubble telescopes, experimented with different bands and wavelengths, and conducted in-depth analysis of star clusters, whether it be their ages, formations, and other characteristics. I found this opportunity to be incredible because not only did it further instill my passion for astronomy, but also allowed me to contribute by publicizing and creating 3D models, expanding astronomy's reach to broader audiences.
Hi, my name is Aubrey and I am from Southern California. SIP 2024 was an informative and incredible experience where I met many new people who both shared my own interests and opened the doors for new opportunities. Despite being only a freshman, I felt welcomed by my peers as they elevated me to the next level while working on astrophysics research, and as we modeled our data. This experience is one I am truly grateful for and one I hold close to my heart.
I truly enjoyed this past summer with SIP. I want to thank all the hardworking mentors, the wonderful interns, and everyone on the SIP team for making all of this possible. I wish everyone luck on their future endeavors. Thank you.
All right, we didn't get the musical chairs, but we do know this. Can we get one more round of applause for Shivani and Steven? They are watching on stream right now, and to that point, mentors like Steven, RAs like Shivani, help kind of hold this program together. We have a small central team, but it's you all that really allow our students to get comfortable on campus, explore those passions and interests, while we are fielding questions from parents about where they are, what they're working on, what field trip is next, what shuttle are they jumping on, and whatnot. So can I just have anybody who has ever served as a mentor stand for a moment so that they can be recognized? Wow. – 16 years, Raja. Has anybody ever served as a PA or an RA and is in the room today? They're outside. Andrea, our fabulous CRE. Great. Thank you. You all do wonderful work. We are going to transition to our third to last and second to last speakers. So may I please introduce Alex Hong and Morgan Lee to the stage.
Hi everyone. How we doing? Okay. So today, me and Alex, we're going to talk about our SIP experience, but from a college track perspective. So first of all, my name is Morgan Lee. I was in Astro 1 and 5 in 23 and 24, and I'm a senior at West Campus.
Hi everyone, my name is Alex. I'm also a senior at West Campus, and I've done SIP for 3 summers and 2 projects in environmental sciences and 1 project in ecology.
All right, so what is college track? We've been in college track since our freshman year. It's a nationwide nonprofit helping low-income, first-gen, underrepresented college aspirants get into and graduate from college. So for me personally, Miss Emily actually encouraged me to apply. I never thought I'd find something as niche as astronomy that I'd get real hands-on experience with. But Miss Emily encouraged me to take the leap of faith, leave home for 2 months, 3 hours away, which is not a lot compared to some other people, some like international interns. It's crazy how far they go, but yeah.
Yeah, so like Morgan, I was also kind of hesitant to apply to the program, but Miss Emily helped me through the process and gave me the confidence to submit my application and find the steps to achieve what I have done so far and change my life from then on. So for my experience in SIP 22, it was the first year after COVID. However, everything was still online, and despite that, I still met many accomplished people from across the world, across the nation, and across the state. Through this, I met Terry Wong, who graduated last year and was Michael's unofficial mentor. And he was my roommate for both, or in 23 and a little bit in 24. We are great friends, and as a result of meeting Terry, I was extremely excited to come back to SIP.
So 23, I came in, 23 and 24. Well, 23 was hybrid, working with half of my group in a different time zone and the other half in the library all around Santa Cruz, trying to find our way around the campus. It was interesting, but we definitely worked through that. We grew some really good personal connections after as well. And so the thing about SIP Astro Research is we have levels of researchers all the way from high school interns up to professors, which was really interesting, getting to see all the perspectives from every level of academia. All of my group mates were great, all of my roommates were great. I want to give a special thanks to one of my mentors in 23 who let me interview her on her path to how she got started in astro. So thank you, Dr. Colette and Dr. Laura.
All right, so for my experience in SIP 23 and 24, they were a little different than Morgan's. In 23, I was down at Coastal Campus, UCSC's Coastal Campus, with my mentor, Megan Molinari, on our project on the social behavior of fish and hormones' effects on their behavior. At Coastal Campus, we analyzed data in a real lab, which was different than my experience in SIP 22, and I really appreciated the opportunity to conduct research and analyze data in a lab setting. One of my crewmates actually came from Turkey, so it was great to hear from her experiences in person as opposed to online. Some of you may have seen the SIP video. We filmed that down at Coastal Campus and down at the beach, and it was a unique experience that I think will have impacts on future SIP interns. In 24, I had a project in environmental studies on the effects of fish effluent on soil pathogen suppression. We were down in the UCSC farm to look and sample plots.
Okay, these are just a couple pictures from the last 2 summers. These are my wonderful roommates, my group mates, and in the top left, it was actually the Lick Observatory. It was an astronomy field trip from this past year. It was incredible. It was my first time ever being in an observatory, which, as an astro major, future astro major, woo! But yeah, also being in SIP, I have a piece of a telescope that I just keep at home. Is a slit mask from the Keck telescopes in Hawaii, which is my good luck charm from when I study.
All right, so here's some of my photos from my SIP experience. I have some photos from 23 and 24, both in person, and some photos from Coastal Campus, the farm, and a photo from kind of near Coastal Campus. It's a kind of museum aquarium where there was a gray whale skeleton. And here is a photo from the last day of SIP 23. Our friends went out to see the sunrise, and we saw a beautiful view, but we were also able to ask one of the incoming freshmen who was out taking photos of the beautiful sunrise, and we tried reattempting this in 24, however, everything was foggy, and unfortunately, we did not get something as beautiful as this.
So post-SIP, I've been fortunate enough to continue working on my research. My mentor from last year, 23, took our project to AAS, and my groupmates are currently working on another AAS poster. So yeah, Astro represent. I'm glad to also be a co-author on those papers.
Yeah, so in both SIP 23 and 24, in 24, Morgan and I were alumni buddies, but my experience as an alumni buddy in 23 and 24 kind of showed me how I could give back to the SIP community, to the interns, and just elevate the experiences of those around me. We're going to continue this through SIP outreach, which we will talk about in a bit, and following SIP, we've been applying to colleges.
Everyone's favorite part of senior year. Yep, college season. But one of the things from SIP that helped me was the Alumni Buddy College Talk series. Shout out to Yael. But through this series, I learned personally a lot of special tips and information about specific, for me, physics programs at different universities. So that helped me narrow down my college list to which I'm applying right now.
All right, so at West Campus, we decided to orient our senior project to aid SIP and college track as they helped us formulate our career goals and kind of set us on a path towards success. We're aiming to present to nationwide college track sites. For example, last week we presented to CT Watts down in SoCal near LA, and to as well as local presentations to encourage STEM within our area. Low rates of high school STEM experiences in Sacramento area are unfortunate, and we need to elevate the experiences and voices of those around us.
So this is where you all come in. Here is our pitch to you. Alumni, you can stay connected to SIP by reaching out to your local school counselors and the SIP ADs, ask for flyers, and set up informational meetings to bring awareness to SIP in your local community. Also, you can share your SIP memories and your stories on Instagram by tagging the SIP UCSC account over there. Thank you. And one more time for Alex and Morgan. Alex and Morgan mentioned that in Sacramento, which is also where I live, there are fewer opportunities to engage in really deep research or in programs in the STEM field. It's a little bit different than being in the Bay Area. So I do just want to shout out that these two took a drive from Sacramento today, as did Colette and Michael from around the same area, as did Tony come in on the train, all from the Stockton, Davis, Sacramento, and I'll shout out Elk Grove as its own city, Elk Grove area. And I really do appreciate you all for coming and making this journey today. I know it is not an easy trip, and I am really glad that you had an opportunity to take part in this program. So our final speaker for today is our Associate Director, Lindsay Lauver.
Check, check. Okay, you can hear me. Good. So I get the pleasure of sharing about all the wonderful things that we've been up to this past year. So many of you know now we are a formal department at UCSC Silicon Valley Extension. And our name is CrEST, Creating Equity in STEAM. And CrEST's mission is to provide life-changing experiential learning programs that build self-confidence, foster equity, and inspire impactful change in our world. By engaging under-resourced and historically excluded students in critical thinking in the context of research,
CrEST aims to advance equity and promote diversity in STEAM fields. We achieve this mission through our three main programs. One is Shadow the Scientists. Shadow the Scientists connects the public with STEAM professionals in real time via Zoom. And these events have been reaching students and enthusiasts all around the world. We also have Python in Research, or PR, which is a free online tutorial that is offered a few times a year. And that teaches Python programming language in the context of astrophysics. I think we have some sessions coming up in February, March. And also SIP, that's why we're here today. You all know, this needs no introduction, but SIP is a summer-long 8-week research internship program for high school students ages 14 through 17. So I'll start with Shadow the Scientists. So although it all started with astronomy, STS has expanded into 10 additional research areas. Just to name a few, it's oceanography, tropical rainforest ecology, volcanology, and even indigenous epistemology. Shadow the Scientists has served 2,724 participants so far this year, and we were able to even hold a couple of dedicated sessions for our SIP interns this past summer. One was new strategies for restoration in lowland wet forests in Hawaii, and asteroids and comets in our solar system. So if you are interested in participating in a shadow session in the future, feel free to scan the QR code on the screen. And if you are a researcher yourself and you'd like to maybe talk about hosting a session, feel free to find me after this. I'd love to chat with you. Or you can also feel free to email Jamika Marshall, who is our Shadow the Scientist Programs Manager. We can talk more about that. Also, if you're interested in setting up a dedicated session for a classroom, we would love to talk about that too. Okay. PR, or Python Research, this year served 609 participants. Like I said, we're going to have some upcoming sessions in February and March. So if you just want to refer back to our website, you'll be able to find more information about how you can sign up for those sessions. And now SIP. Wow, look at those beautiful faces. I feel like my thunder has been stolen, though. Lots of people have been showing this photo, so. But it's a good one. Everybody's represented there. You can see how much we have grown over the past 16 years. We started with 3 interns in 2009, and we've just skyrocketed since then. Last year, we had 394 students, but, we were a hybrid year that year. So some of them were remote students and some were in person. This year, we were completely in person, and so we brought 395 students to campus, which is just really, really remarkable. So some stats this year: 57% of our participants were female interns, 61 were from California, and 26% were international interns. 34% received need-based scholarships too. So we had 119 projects in 26 different subject areas, and we've been receiving more applications than we ever thought imaginable. And so we're really excited to see where we land this year. I feel like the word is really getting out about SIP. 9% of our interns received need-based stipends, and we were able to provide about $62,500 in travel support for our international interns. We've also been able to expand our outreach efforts in Arizona, California, Colorado, India, and Kosovo, just to name a few. And obviously, we reached out to so many more communities via Zoom. Lastly, we were able to welcome our brand new, not brand new, she started in August, but new SIP Assistant Director, Emily Belko. We are so excited that you are here with us. Emily comes to us with a wealth of experience and was even a partner of ours at College Track for many years. So can everybody just please welcome Emily with me? All right, and then this chart just shows how much our global reach has really broadened to. We have students from Indonesia and Ghana and really all over the place. So word is really getting out. All right, with that, I really want to thank all of our SIP staff this summer for creating such an engaging experience. So can you please stand if you are here? Anand Lalria, Acting SIP Assistant Director / SIP Operations Coordinator Extraordinaire. Andrea Rosas, our Coordinator for Residential Education.
our wonderful program assistants, Aditi Madan and Sanjana Karthik and Shalom Yifru. Do we have any RAs in the building? Any residential assistants? No? Okay, that's okay. We got Andrea, so that's good. And then any SIP mentors? I guess we already had a SIP mentor stand, but if you could stand again, please, Stefan. All right, and then Abby Davis is our CrEST Global Liaison, but she's currently fast asleep. She lives in the UK. She cannot be here tonight. But lastly, of course, Raja.
Look, we can't do any of this without your support. I want to be absolutely clear about this. Lindsay talked about a range of programs. There are many aspects to SIP. There are many aspects to Shadow the Scientist. There are many aspects to Python and research. And we really, all aspects of our work relies on philanthropic gifts. More than ever, we need your help. 16 years from the start of SIP, there's a huge number, you can see their names on the selfie frame. There's a huge number, more than 2,000 alumni are members of the SIP family. Parents are members of that same SIP family. Our mentors and faculty and our outreach partners are part of that same large family. We need you. We need you. No gift is too small. Please consider supporting us to the extent you're able to.
And these are just some examples of what collective dollar amounts can do in terms of impact. For example, $1,000 would cover a full need-based stipend for our most under-resourced domestic students who would use funding for airfare, or maybe would miss out on earning employment income over the summer by participating in SIP. It also would help with supplies and various expenses over the summer. $4,750 would provide a full need-based tuition scholarship for an intern as well. So these are just some ideas, but of course anything is so appreciated. Okay, we're gonna play a brief video from one of our SIP interns, Franklina Peter. Franklina attends school at Shanti Bhavan, a residential school in Tamil Nadu, India. And you may have heard about Shanti Bhavan from the Netflix documentary Daughters of Destiny, which we really recommend that you watch. It's fantastic.
Hello, my name is Franklina, and I had an amazing opportunity of participating in SIP this summer. And I think SIP has impacted my life in very different ways, and I'm really happy that I did take part in SIP. Academically, I think SIP helped me cement out what I want to do in the future. I did my research in biomolecular engineering, and we learned about cancer and its different treatment or diagnostic ways. And I think it has really helped me cement that I do want to go to the oncology field. As of now, I'm thinking about becoming an oncologist, and I really like the fact that SIP has helped me actually make that decision. I think one of my highlights were working in a team with my fellow interns and getting to learn more about my passion with other people who share the same passion as me, and I think that is very motivating. On the social side, I personally believe that SIP has helped me grow a lot. I considered myself an extrovert before I came to SIP, but I believe that while I am an extrovert in Shanti Bhavan, I never really knew what it meant to be an extrovert until I visited SIP. America is like something I've never been to. It was a really different place, it was new, and me going to SIP, like leaving my family behind, my Shanti Bhavan family behind here, I think I was able to meet way more people and get a chance to look at their life, their traditions, their cultures, and I think that was one of the best highlights for me, getting to know that there are other people in the world who maybe share the same interests as me, who do different things, have different opinions, and learn more about those thought processes. I want to thank all the SIP members for giving me the scholarship. Given my socioeconomic background, I'm 100% sure I wouldn't have had an opportunity to do this research if I wasn't given the financial aid that I was. And I'm really happy that I did get this research opportunity. It has impacted me in ways I can't even start to explain to anyone. Thank you very much.
All right, if you'd like to watch more testimonials from our SIP interns, feel free to visit the link that's on the screen. And you can also watch our global showcase there too, and that way you can learn a little bit more about our cohort this last summer.
I'll just say a quick word about the global showcase. We run it for 2 summers in a row, and it's something where in the middle of the summer, students talk about things other than their academic research. They talk about their culture, their home, food, clothing. We really are trying to encourage students to bring their whole selves to this program. For too long, academia and STEM has really required people to shed parts of themselves to join the academy, and that's just not right. And in our small way, we're trying to change that through our global showcase, so I encourage you to watch that. Thanks.
All right, if anything we've shared tonight has resonated with you and you feel compelled to give, you can scan the QR code on the screen, which will take you to the UCSC donation page. And the URL, let's see, if I click one more time, it should show up. There we go. If you go to that URL, you'll be able to go to our CrEST department donation page, which gives you the option of making a pledge if you're not ready to give. Feel free to reach out to me if you have any questions about giving or pledging donations. And you can also, try any of these other options as well. If you'd rather send a check, you can do so with those instructions, and then also maybe consider selecting CrEST as a beneficiary through the company's matching program if you have one. Right. And with that, Emily?
Round of applause for Lindsay and Raja. Thank you, thank you, thank you. All right. This is the end of our formal presentation. So again, we want to say thank you, parents. Thank you, thank you, parents. Thank you, parents. Thank you, faculty members. Thank you, interns. Thank you, mentors. Thank you, RAs. Thank you, SIP team. Thank you, CrEST team. And we also want to thank our partners and friends here at Google for helping us to put on this event year after year. It's been really, really amazing to work with you all. So thank you, Angela. Thank you, Kunal. Thank you, who else do we have? Chris. Thank you, Sydney. Thank you, Madhukar, for all of your extra time, all of the effort that goes into allowing us to use this venue. So a quick round of applause for our Google crew. You see in my hands and arms 3 gift bags. So if you went up to that swag table and you filled out a raffle ticket, you may be eligible to win one of these 3 fabulous mystery prizes. If you did not fill out and get a raffle ticket, that is okay. I am going to excuse you over to the dessert bar to grab a few more snacks, because that is a prize in and of itself. But I would like to invite Anand and Angela up to the stage for those who would like to participate in the raffle. You must have your ticket. You must be here. And if you don't feel so lucky, I think there's 100% chance that there might still be snacks out in our pre-function area.
Thank you, thank you. Can we also get Madhukar on stage, please?
Yes.
Please, Madhukar. Thakurta, Enterprise Platforms Engineering. Let's give him a big round of applause, please. Yeah.
And my boss.
And Angela Patman. It should be on.
1, 2.
Angela and Madhukar and Google. They've been very supportive partners. Madhukar's daughter went through SIP 2 times? 3 times? 3 times. Madhukar actually was a parent speaker back in our SIP 2022 reunion that happened in Palo Alto. But in 2023, we brought it back to Google, and we're back here at 2024. So thank you for all your support. Thank you, Angela, for making this happen.
You're welcome.
2-3 months ago, when we were starting the planning for this reunion, Angela was like, I'm here for the first meeting, but I might not be here for the next meeting. Kunal Malik came into the picture. We love him. Good director, former Facebook, but he's here now at Google. VP, yes, support. If my Gmail does not work tomorrow, I'm just sorry, yes. And also, I had to say there's one more thing. We're doing one more thing at the reunion. Now, who can tell me where you've seen the one more thing pop up before? WWDC, okay, very good. But we've got one more thing today. We've got a raffle for everyone. Thank you for everyone that showed up before the program started at 7 and stayed till the very end. A lot of familiar, supportive faces. SIP wouldn't be SIP without all of you, and we appreciate all your support and donations going into 2025. So with that, I'll bring the box, if my PAs can bring the box, with the raffle tickets. Angela will be the MC from here on out, and then Madhukar, you get the honor to pick the names. Okay. It's all yours.
Wait, not a drum roll. Angela's part.
We're very coordinated.
Yeah.
Okay, so I'm going to need you guys' help. We don't have a drum roll, and I think our steel pan has gone for the evening. Oh, no, we're going to do a little different. As Madhukar is pulling the third place raffle winner from the box, you guys are going to go sip, 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 until he pulls the name for each person, okay? So here we go. Come on, 1, 2, 3. Sip, 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 sip. Third place winner is
Kin Wang. Kin Wang.
Whoa! Ken, would you like to say anything? It's your special day.
Oh.
Come on up. This is for you, Ken.
I'm here because my daughter, Anna, was a SIP participant way back in 2017, and we have tried to keep in touch also since then. So.
Well, thank you, and thank you for coming and joining us this year. Enjoy your gift. Be careful. There you go. Okay.
See, SIP alumni, keep coming to the reunions. You'll win a Google swag bag.
Okay. All right. I need you sip, 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 sip. Second prize winner is...
We have a second prize for Evelina Young.
Woohoo! Congratulations, Evelina. Would you like to say something on your special name?
Yeah. So my name is Evelina Yang, and I'm the mother of Arthur Chang, who was a SIP intern last summer. And he has such a great time. I just cannot tell you how much he has enjoyed the experience. And so he made a lot of good friends, like James. You know, he's been telling me about them. You know, after the program ended, he was still talking about it. And even though they didn't go to the same school, and I think there were about 10 other students from our high school who was, in the SIP program last summer. It's absolutely fantastic. So my husband and I, we were engineers, you know, and we were very impressed with the work, the research that they did. And when we went to the final presentation, so we were very impressed with the presentation that Arthur and his two group mates did. And they had a fantastic mentor and a professor who was like, great. And they did like great work, and they published a paper after the summer at the Baylearn Machine Learning Symposium. It was like they study, the how to improve. I'm not saying, hey, Arthur, can you tell me what? Yeah, okay, he can tell you the research, yeah. So, trying to optimize, like the LLM influence. Yeah, well, you can tell I'm not an expert in that. So it was absolutely wonderful experience. Thank you so much. Thank you, Professor Roger. Thank you, Anand. And Arthur actually had an accident, on one of the beach day, he was hit by a flying saucer. And Anand really took good care of him. Yeah, I'm just like so impressed. Thank you very much for everyone.
Thank you so much. Oh, that was wonderful. Thank you. Thank you. All right, here's for our big one, guys. Now I'm going to need a really, really loud sip, 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 sip. Stand up. Come on. Stand up, stand up, stand up. Sip, 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 sip. This is for our first prize raffle winner. The name is
Amar Astana. What is it? Amar Astwana. Yeah. Aswata. Sorry, I'm butchering the name. Sorry, very sorry. Amar.
Is Amar not here?
Amar's not here?
Is Amar not here?
You have to stay until the very end.
Yes, so we're
Okay.
going once. Going twice. It's gone.
Okay,
All right.
we'll pick one
Come
more.
on. One more. We're going to do one more. Big old sip.
Sip,
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 sip, sip, sip, sip, sip, sip. All right. The name is?
Ting Su.
Oh my gosh. This is the family. Come. Come on. Congratulations.
Those of you who want to study probability, what's the chance that that happens in the family?
Okay, return that one to back.
Okay. That's very
Would you like to say
nice.
anything?
I just want to say, for high schoolers, sometimes they just doing all the exam, all the paperwork, all this stuff, never had experience, and teacher has no time. So I really feel if they have the chance to come to SIP, even sometimes she may feel what I'm doing, maybe feel I don't understand, terrified, but actually they learn without knowing it. So I think it's very good experience. And my daughter is really, I think she wanted to encourage girls to do STEM when she was in high school. So I think SIP is doing very well. I look at the percentage. So it's good. Yeah, thank you. Because a lot of girls, I feel, they are not confident. Because I realize some of the girls are actually pretty good, very good. But then when they go to college or go to work, they say, oh, only people like her, the number one, number two, can do STEM. They all feel I cannot do it. But for guys, they feel I can do it, right? They don't have to compare the number one. They just go. But many girls feel they have to be number one or number two to do it. So I think they lost a lot of opportunities. So I feel SIP is doing a good job. Thank you.
We get another one.
Well, maybe we should tell a joke and let someone answer it. Instead of it. All right, I'm going to tell a joke. The first person that can answer this gets this bag. All right? You have to shout it out immediately. All right? What do you call a cow with no legs? Oh, we know. Everybody knew it.
Going back to the raffle.
Everybody, back to the raffle.
Good job.
That joke must have gone viral.
It's a yeah. Audience. You know what you're gonna get.
You guys are too darn smart. All right, we're gonna go on to the raffle. Ground beef. These guys are geniuses. All right, we're gonna regift the second place raffle. All right, how do we do it? Sip, 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 sip. And second place winner is
Ivan Yon.
Oh! Congratulations. Congratulations.
Thank you.
Here you go.
Hi, my name's Evan. I was a SIP intern at this past summer, and I did psychology 2, and which is like studying like brain waves on like perception. It was really cool. Yeah, really fun. Thanks for this. What is it? Oh, it's a water bottle. Thanks for the water bottle. I greatly appreciate it. I will add it to my many water bottle collection. Thank you so much. Thank you, Anand. Yes, thank you, Raja. Thank you, all the SIP staff.
Thank you. So I just want to tell you guys, this is my 4th year, and it's always so lovely to see your faces, and some of you very familiar faces now. So thank you for attending and for supporting this cause, Raja. We love you. Emily, thank you for your partnership, as well as Lindsay, right? I always get it messed up. Don't want to leave without shouting out our very, very awesome production team. Can you guys show them some love?
Chris Waters, ladies and gentlemen.
Chris Waters, we have Tony over here and the whole team. Want to shout out Christine Borg, who's not here tonight, but who gave us her YouTube channel so that we can stream, very important. And I also want to shout out security and catering and our ladies at the reception that got you in here. So it does take a village, and so we appreciate you guys, and we hope to see you again next year.
Thank you, everyone. Appreciate it. Thank you.